organizing everything today. Don't get in the habit though, I don't do that very often. But that's my Friday gift to you this week.
Aww.
We survived the first week.
Thank you.
You're welcome. All right, so what is a complex number? Do you remember? So basically every number is a complex number. But you're more familiar, usually we start seeing the word complex number when we start throwing i's into things. So I is the imaginary number. I squared is equal to -1. So if I squared equals -1, then that means I is the square root of -1. Okay? So a complex number itself is anything written in the form a plus bi. This is the standard form for complex numbers. I am going to be a little bit nitpicky on that. Most of my directions will say write it in standard form. So if you put like 3i plus 2, I'm going to take off a half. I want you to write it the real plus the imaginary, 2 plus 3i. That's just our standard notation. A is what's considered the real part of the number. B is the imaginary part because it has an I in it. All right. So far, okay? So with this, you probably haven't classified these before. It's not going to be a huge emphasis, but I do want to kind of touch on this. Any a plus bi, that is a complex number. Okay, so every number that we've seen so far is a complex number. 3 is a complex number. We can also say if there's no imaginary part, so like 3, then it is a real number. Okay, if you don't have a real part, so if the a is 0, that would be a pure imaginary number. And if it has both parts, it's non-real complex. Okay, so a real number is like 5. A pure imaginary number would be something like 2i. Non-real complex would be -3 minus 4i. But all three of these are still considered a complex number. So let's classify some numbers here. So I want to identify these as real, complex, pure imaginary, or non-real complex, using all that applies, so we can have more than one. So 13i, what would that be? Pure imaginary because there's no real part. And what other term? Complex. All of these are complex. What is B? Well, I said all of them are complex. And then it's one of the other three. So is this pure imaginary, real, or non-real complex? Non-real complex because it has both parts. It has the real number and the imaginary number. So pi. Does it have an I with it? It's real because it doesn't have an I. And what else would it be? Complex. Okay. I'm going to put a trick question there with pi, but didn't have an I, so we still consider that a real number. Do you guys see the difference between these three? So let's just practice working with these i's. A few things. When we start encountering these problems, you get an I anytime you have a negative under your square root. So if I say square root of -5, You know you can break apart square roots, right? So that's like a radical 5 times the square root of -1. And what's the square root of -1? I. So this is radical 5 times I, or I think your Algebra 2 curriculum last year put the I in front of the radical. Either way is fine. Okay? So anytime we have a negative under a radical, we will take out that I. So let's just practice that. So what is the square root of -1? I. That's even the definition. Okay, square root of -16. Square root of -8. So there's a negative, so you have to take out the I, and then remember breaking down your square roots. So you could break it into a 4 and a 2. Square root of 4 is 2. We still have that radical 2. So did you guys write it as like 2I radical 2?
Yes.
Okay. Trying to match the notation you're familiar with. So keep it consistent. All right. So if we start doing operations with these, one thing I want to caution you on. If you multiply these, you need to pull out the negatives before you multiply. Okay, so if I just gave you square root of -4 times the square root of -9. If you just multiplied this, you would have the square root of 36, which is 6, right? But if we reduce these first, what is the square root of -4? What is the square root of -9? If you multiply these, what's 2I times 3I? What is I squared equal to? -1. And 6 times -1 is -6. If you don't take out those i's and you multiply them, you get the wrong answer. You're off by a negative. So if you're doing any multiplying with radicals, you need to pull your i's out before you put those radicals together. All right, so let's try. So I can't do the square root of -7, but what could I do? We could take out the I, at least, to make it I radical 7 times I radical 7. Since we've taken out those i's, now we can multiply it together. So I times I, square root of 7 times the square root of 7 is square root of 49. What is I squared? What's the square root of 49? And so we get -7. Okay. D. With division, it isn't quite as big of a deal. You could take out these i's first, or we can go ahead and just simplify first. Now I'm sure you're used to remember you can't leave a radical on the bottom, right? We do have a shortcut. If both the top and bottom are under a radical, you could go ahead and divide these numbers before you do the square root. So that would save us a lot of time rather than trying to get the radical off the bottom first and then reducing. What is -20 divided by -2? 10. Can you reduce the square root of 10? No, so that's it. If you took out your i's first, you're going to get to the same thing. I radical 20 over I radical 2. What happens to your i's? They cancel out anyway. So with the division, you can pull them out or leave them in. Either way, we'll get to the answer. All right. Am Am I going too fast?
No.
All right. Do you remember how to add and subtract?
Yes.
Basically, like terms. The I doesn't change anything, it's just add like terms.
Yep.
The only thing I am picky on, I want standard form. A plus BI form on these. So, you guys do A and B. You don't need me to do it for you. You do it on the chart. So for adding, just add like terms. 3 plus -2 is 1. 5i plus 3i is 8i. 1 plus 8i. With the subtraction, what should we do? Distribute that negative, and then we just add. So 6 plus -3, -4i and -6i, is -2i. C, I'm asking you to multiply. What do we need to do? So first, 10 plus 35i plus 6i plus 21i squared. Okay, 35i plus 6i gives me 41i. What is 21i squared? Then positive 10 and -21 gives us -11 plus 41i. Do we need more examples of that? Okay. Couple more things I want to review with these eyes. This is probably the one that you're the most rusty on.
I still don't know how to do this.
Still don't know how to do this. Okay. And I'm going to tell you right now, when I put this on a test, I'm going to say that you have to have work. Because we all know there's that person that's like, well, I don't know, I'm just going to write down -1 and hope for the best. Well, there's no such thing as just guessing and getting it on these. I'm going to make you show me something. So I know you understand it. Okay? All right. So if I asked you to simplify this, all right, if we have lots of time, we could just, write out 15 I's. That's what we want to do. Right. No, not at all? Okay. So what do we know about I's? Every time we get I squared, what does that turn into? -1. All right, so let's start there. We want to break this up using I squared. All right, if you have 15, how many groups of 2 can you make? 7. Okay, 2 times 7, that's 14 of them. We still have 1 left, so I still have an I remaining. Okay, do you guys see that this is equivalent to I to the 15th power? All right, now we start simplifying. What is I squared? -1. What is -1 to the 7th power? If you use your calculator for this, it's going to look the other direction, pretend I don't notice, but make sure you put your -1 in parentheses, otherwise it'll give you the wrong answer every time. Okay? So, what would that give you? -1. If your power is odd, it'll be negative. If it's even, it'll be positive. So we get -1 times I, which is -I. The only answers you will ever get on these are 1, -1, I, and -I. Okay, let's try another one. So I to the 22nd power. How would I write this? $11. Do we have any left over? No. What is I squared? And -1 to the 11th power? That's how we do it. Do we need more? Not at the moment, but day before the test, it wouldn't hurt to run through some just to make sure. Okay. Makes perfect sense while I'm doing them, but when you have to do them on your own, different story, right?
Actually, we should talk about traffic. It's at the time.
All right. When I'm asking standard form, that's a plus bi. That means you can't have an I in the denominator. Do you remember how to move it?
Sorry, Mary.
It's okay.
Multiply by, what do we call it?
No.
Conjugate.
Oh my, let's go.
Is that what you said?
Yeah.
Okay, conjugate is the same thing, but we just changed that sign.
It's rather table, so
All right. When you multiply fractions, you multiply the tops, you multiply the bottoms. We have to FOIL here. So 3 times 5 is 15, plus 3i, plus 10i, plus 2i squared. On the bottom, we get 25. The outside and inside cancel because they're conjugates. Positive 5i, negative 5i. Are you guys okay if I don't write that down?
Yeah.
Okay. Minus I squared. 2i squared. What does that equal to? Negative 2. So it's like 2 times negative 1. So 15 plus negative 2 would be 13. 3i and 10i is 13i. Okay, on the bottom, this is 25 minus I squared. So that's like 25 minus negative 1, which is 26. Okay. Notice my directions. I said standard form, a plus bi. That means we have to break this fraction up. So 13 divided by 26 is 1/2 plus 13i over 26 is 1/2 I, or I over 2. Did I lose anybody on that one? Lots of multiplying and simplifying there. What about B? We don't even have to do the full conjugate there because there's only one term on the bottom. So just multiply by I. So we get 3i over I squared. I squared is, so 3i divided by negative 1 is just negative 3i. Can we handle one more thing?
One more time.
One more.
Maybe.
And then I promise this is it.
Let's go.
Okay.
A lot of coffee.
Oh, it's not that many. Don't jump ahead.
Come on, it's Friday. Give us homework.
You have Friday, Saturday, Sunday, Monday, advisory.
I can't do
all kinds
homework
of
on that
time.
weekend.
Okay. Let's look at this one.
We gotta go catch bugs all weekend.
All right. What would I do first?
Simplify.
Simplify. What do can I do something with that radical?
Gotta take out the I.
Gotta take out the I. Okay. What about, can we break it up? Are there any perfect squares go into 128?
Probably.
There
There is.
There
I
is.
think so, but I mean, I don't know what they are right now.
16.
16. There's a bigger one too.
64.
30.
6.
Okay, let's go. Let's go, let's go.
Okay. Square root of 64 is 8. We have an I and we have a radical 2. All this is over 4, but I said standard form, so what do we have to do?
Simplify.
You just put each one over 4. So negative 8 over 4 is negative 2. 8i radical 2 over 4. So 8 divided by 4 is just 2I radical 2. So B, how would I break apart the negative 200? 100 and 2. Square root of 100 is 10. So reduce, 10 over 5 is 2, plus 10I radical 2 over 5. Almost the same answer.
Wow.
Okay. We have about 15 minutes. There are 2 things I need you to do. Okay. I kept forgetting to tell you, I know some of you have noticed on Classroom, the very first day, I did post a little survey that'll take you maybe 2 minutes to fill out, just to let me get to know you a little better, let me know if you're interested in dual credit, those things. So if you could fill that out, I would greatly appreciate it. And then homework, this